Hey everybody, welcome back. Let's get started on this little quick task. I decided to make an extra video on how to memorize the equations for cylindrical and spherical. There's a lot, and it feels like there's an awful lot. But if you dig deep and you remember your stuff from your trigonometry and you do some simple substitutions, we can reduce what we need to memorize that's new to very little. Let's start with the basic trigonometry. You learned this in the trig class or pre-calculus. If we have a right triangle, one leg is x, one leg is y, the other leg is r. Just like the distance formula will give us, hopefully you guys remember distance formula or the Pythagorean formula here. X squared plus y squared equals c squared. In this case, r squared. So that's one of them we need. And this, when we convert it to 3D, looks like this triangle right here. Okay, because the X is right here, the Y is right there. But in 3D, we need the vertical components. So that's where this part comes in. So on any regular point P up here, that's our P, that's on the surface of the cylinder or sphere at this point. I didn't actually describe it either way yet. Let's start with cylinder. Actually, let's go back to the trig one stuff. So from here, the other things you get from trig are cosine theta is adjacent over hypotenuse. And sine theta is opposite over hypotenuse. So that's not new. What you may be unused to writing it as is clearing the fractions by multiplying through by r. X equals r cosine theta and y equals r sine theta. I didn't write these out ahead of time because this is an impromptu thing, and I want to just show you how you can go about memorizing it. Okay, so what else can I get from this picture? Just the 2D component. Because looking at the same triangle in 3D is harder to see, harder to read than looking at it in 2D. And you've seen the 2D one before. So we've done cosine and sine. What's the third major trig function? Tangent. Tangent theta is opposite over adjacent, y over x. Okay. So this looks like if we wanted to go from polar, we used to call it polar coordinates in 2D, polar to Cartesian or rectangular, we need theta and r. We just plug them in, we get this. If we want to go from Cartesian to polar, start with xy and end with r theta, we have to plug in x and y here to get r squared. Take the square root, we'll get r. And plug in x and y here, and you'll get tangent theta. You do tangent inverse, you'll get that. So I'm going to put this one down here because this one is one of the ones we should memorize. So we'll just make a box over here on the left. Those are our trig equations that we had before. Those aren't new. Okay, so what's new in 3D? Well, we have a z component. So on a cylinder, if we put the base right here, and that's 0, 0, r is still there. We're sweeping out an angle theta. We got an r. And the other thing that identifies the cylinder is the height of the cylinder. And the height of the cylinder is z. So for cylindrical coordinates, what is new is z. Z equals z. We need to list z in both of them. So z equals z. And that's all that's needed for cylindrical. We already had everything else for cylindrical in our trig set. Okay. Now switching to spherical. Any point from the center is again a distance formula. And we're going to use rho instead of r. So radius here is rho. And the good thing about doing distance formulas in multiple dimensions, it's the same thing as just adding another component. So one new one you need to memorize is rho squared equals our good old x squared plus y squared plus z squared. This is our x squared and y squared. We add a z component, we're adding that squared. So that's a new one that you need to know. If we look at the picture, and we draw in, this would be rho right here. The angle phi is off of the z-axis, and that makes it this angle right here. Okay. The important thing you need to remember is the addition of the phi part. We added rho, we need to add phi. Phi is going to be, if we look at the picture, because this is r right here, we can do tangent phi. You don't need tangent phi. Let's do, let's see, that's the right angle here. Well, we could. Let's go with tangent phi. Tangent phi off the triangle, opposite over. All right. Opposite over adjacent. This looks wrong. Let's not go with tangent phi. Let's go with cosine and sine. Let's start with those. Cosine phi is adjacent over hypotenuse, z over rho. So rewriting it like I did with these up here, z equals rho cosine phi. And if I look at the sine one, sine theta is opposite over adjacent. Not theta, phi. R over rho. So R equals rho sine phi. Those are the only three new ones you need to memorize for spherical. Okay. Cylindrical makes sense. We need the z equals z. That makes sense. As long as you know rho is radius, you're good to go. These are what you need to memorize. Our trig equations and these three new equations. Now, how can I generate all the other ones, you say? Well, it's all substitution from here. Let me add another piece of paper next to this one, or overlapping this one. Let's just look at the equations we got and go, how can we get the other ones? Well, if I need rho, notice I've got x squared and y squared, and I got x squared and y squared here. I could say rho squared equals r squared plus z squared. That's just taking r squared equals x squared plus y squared and plugging it into the rho squared formula. So we can come up with that one now, there. Now, the fun ones that look like they're the hardest to memorize, the x, y, and z in spherical, because they've got phis and thetas. Well, let's just come up here to our x, y, and z. X is r cosine theta, y equals r sine theta, z equals z. And I'm going to use the two equations I just memorized. Z equals rho cosine phi, and r equals rho sine phi. If I plug these in, boom, 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 boom. I'm going with boom. X equals rho sine phi cosine theta. Y equals rho sine phi sine theta. Z equals rho cosine phi. Those are the three ones that are the hardest to memorize because they got a lot of, let's face it, they got a lot of shit going on in them, right? Now, we could add the tangent phi in, but we don't need it. I know the book has equations for switching from spherical to cylindrical. Why bother memorizing those? You don't need them. If you really need to go between cylindrical and spherical, I'm sure I could rederive them all from these 7 equations right here. But you can always switch back to Cartesian and go forward. And I'm sure that's exactly what happens in the process. So memorize these 7. And I'm not even going to bother saying z equals z because that's dumb. That makes sense. So these 4 you already should know. And if you don't, you might want to refresh your trig a little bit because that's like the basis of trigonometry. And then our new additions for spherical. An upgraded Pythagorean formula for 3 dimensions. And just remember, we got these look like these, just slightly different. These are the tougher ones to remember because you're dealing with rho and phi and you haven't dealt with those before. But you can do it. That's not that many. I believe in you. I know you can do it. You can always derive the rest on your own. Now, if you're one of those that just like, I don't want to have to like plug stuff in and do that, you can the other way. If you really need to know them all, if you don't want to do any substitution, make flashcards. Not on your app. I know there's apps that make them. When you have your phone in your hand, you don't want to do flashcards. You want to hop on Twitter, TikTok, Instagram, WhatsApp. There's a lot of things you want to hop on. Don't do it on your phone. Make flashcards with good old paper. Index cards. You don't even need to make them this big, but if you like them, I took these. I was a cheap college student and I cut these in force and made my flashcards all super small. Now, in hindsight, I probably should have just cut it in 2 and made them a little better because they were too small. But flashcards can do it, and then you can just flip through them while when you have a few free minutes, if you're taking the bus, if you're using the restroom, at home. Hopefully you're not doing this in school. There's ways to do it. Just remember, those 7 equations will get you the rest. Peace.